Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 53, for broadcast on the 1st of June 2020. Coming up on SpaceTime, Americans fly into space from American soil for the first time in 9 years. Astrobiologists on Earth put the technology of the new Mars rover through its paces. And Japan says farewell to an old friend with the final launch of their H2 rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
American astronauts have been launched into space from American soil for the first time in 9 years. The SpaceX Demo 2 mission successfully blasted off from Space Launch Complex 39A at the Kennedy Space Center at the Cape Canaveral Air Force Station in Florida. NASA astronauts Robert Behnken and Douglas Hurley were aboard the Crew Dragon 2 capsule for the historic Demo 2 mission atop a Falcon 9 rocket.
At this time, weather is go for launch.
Dragon, SpaceX, you are go for Section 7, close visors and arm launch escape system.
SpaceX Dragon in 7.2, visors are closed, we're arming launch escape system.
Launch escape system is verified armed. Propellant load has started. Stage 1 cryo-helium load started. Stage 2 RP1 load is complete.
SpaceX Dragon displays are configured for launch.
Copy. Bob, Doug, on behalf of the entire SpaceX team, it's been a huge honor to help you get ready for today's historic mission. Know that we're with you. Have an amazing flight and enjoy those views of our beautiful planet.
Thanks, Jay. It is absolutely our honor to be part of this huge effort to get the United States back in the launch business. We'll talk to you from orbit. Thank you.
Dragon has transitioned to terminal count and is on internal power. Stage 1 LOX load closed out. Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
America has launched. And so rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
T plus 30 seconds into this historic mission.
Falcon power telemetry nominal.
M1D throttle down.
We're throttling down to get ready for the period of maximum dynamic pressure. Reports say all systems are go.
Vehicle is supersonic.
We've exceeded Mach 1 on the Falcon 9.
M1D throttle up.
We're throttling back up to full power as we're through max Q.
Copy, 1 Bravo.
And we heard that 1 Bravo call out. That's just the second abort zone that they're in. They'll continue to be on this until the first stage has done its job and they switch over to the second. At this point, Bob and Doug pulling about 2.3 Gs, 2.3 times the Earth's gravity, already moving at over 1,500 miles per hour.
We've heard the call out for MVAC engine chill. That's getting the MVAC engine ready to light. That'll come at about 2:44 into flight. Right now, everything continuing to look good. Next major event coming up is going to be the triple. We'll have main engine cutoff of the 9 first stage engines, stage separation, and then ignition of the second stage engine to continue to carry astronauts into orbit.
M1D throttle down.
We heard we're throttling down the Merlin engines on the first stage. And we have MECO.
MECO.
2 Alpha.
Falcon stage separation confirmed.
Copy 2 Alpha.
MVAC ignition.
All right, we have stage separation confirmed. The first stage beginning its flight back. The second stage being powered by that single Merlin 1D vacuum engine has ignited and is now carrying Bob and Doug into orbit. So they're going to continue under the power of this second stage.
Stage 2 propulsion is nominal.
Which will cut off at SECO, or second engine cut off at about 8 minutes and 44 seconds into today's flight. You heard the call out 2 Alpha, so they're now in the longest abort zone that carries them all the way from about North Carolina up the eastern seaboard almost to Canada. Things looking good, though, getting good call-outs, nominal propulsion on that second stage. Bob and Doug continuing to make their way into orbit.
Dragon SpaceX, nominal trajectory.
Acquisition of signal in Bermuda.
SpaceX Dragon, nominal trajectory.
All right, here in nominal trajectory, so Dragon pointed in the right direction, continuing to make their flight uphill. Heard acquisition of signal Bermuda. That's one of the other ground stations that they're using to get telemetry and data back from this spacecraft.
Stage 2 propulsion is still nominal.
Bob and Doug flying at more than 5,600 miles
Dragon
per hour.
SpaceX, nominal trajectory.
Already almost 200 miles downrange from the Kennedy Space Center. Nominal trajectory continuing.
That first stage with the grid fins deployed, it's making its way back to attempt to land on our drone ship, Of Course I Still Love You Today. And we're just about a couple minutes away from the entry burn, and that's where 3 of the 9 Merlin engines do ignite to help slow the vehicle down as it re-enters back into the Earth's atmosphere. And then after the entry burn will be the landing burn, which is just a single engine
Dragon SpaceX, nominal trajectory.
And you heard
nominal
starting chill for entry burn.
There's that call out. They are still on a nominal trajectory on Dragon, still on second stage, and that's that MVAC engine on second stage.
Meanwhile, that second stage continuing to power Dragon into orbit. Again, if you're keeping an eye on that timer, that's going to continue to burn until 8 minutes and 44 seconds into flight. So a little over 2 minutes from now, we'll hear the call out SECO. It'll then be a little
Stage 2 propulsion is still good.
A little over 3 minutes until Dragon physically separates from the second stage of the Falcon 9 after the upper
Dragon
stage gets
SpaceX,
a chance.
nominal trajectory.
Dragon copies, nominal trajectory.
Just about 10 seconds away from that first stage, starting that entry burn.
Stage 1 entry burn startup.
And there is that entry burn beginning.
Signal,
This burn lasts about 36 seconds long.
Stage 2 FTS is saved.
While that entry burn continues, we're just about a minute away from SECO. We'll have a number of events all happen in rapid succession. It'll be the second engine cutoff.
Stage 1
we'll be looking for that stage 1 landing burn shortly after.
Yeah, actually just within a few seconds of each other.
Terminal guidance.
MVAC throttle step.
We are coming up 25 seconds or so away from SECO, or second engine cutoff.
This is also the point where Bob and Doug are experiencing their highest G-force. We're seeing the counter tick up to right about 1.8.
Copy Shannon.
You heard Shannon, so that just means they're in their final abort zones. If they were to abort at this point, it would either be an abort to orbit or to land off the coast of Ireland. Standing by for second
Stage 1 landing
cutoff
startup.
confirmation.
MVAC throttle step. MVAC shutdown. Stage 1 landing layer.
Confirmation of SECO's second engine cutoff.
Now we are waiting for our first stage to make its way to our drone ship, Of Course I Still Love You.
Dragon SpaceX, nominal orbital insertion.
Confirmation nominal orbital insertion.
Nominal
Stage 1 landing leg deploy. Falcon 9 first stage successful.
Falcon 9 has landed. This is the first Falcon 9 to carry humans to orbit, so very exciting for us.
We did hear again that call out, good orbital insertion, so that means Falcon 9 and Dragon right now exactly where they're supposed to be.
And we need an FRC on recovery 1.
And it's right at about 12 minutes when Dragon will separate.
And before separation, before Dragon initiates separation from the second stage, they do ensure that the vehicle is not spinning and it is in good condition before we separate.
That's right. The upper stage does small attitude maneuver using some cold gas thrusters built into the rocket body itself.
Exactly. So we do expect that separation to occur in about a minute from now, but they do wait until they have full confirmation that it is ready to separate.
200 kilometers over planet Earth, or a little over 124 miles, traveling in excess of 27,000 meters per second, or about 16,000 miles per hour. Again, we're just standing by. That separation event should be coming up shortly. Then they'll begin a series of checks on the Draco thrusters that are going to be used to maneuver and then power Dragon on its flight to the International Space Station. Standing by for separation.
Expected loss of signal, wallops.
It sounds like we had an expected LOS loss of signal with one of the ground stations. Waiting for confirmation now of that.
Dragon separation confirmed.
Countdown 1
Dragon separating.
Separation confirmed.
And there's that call out. Dragon is now officially making its way to the International Space Station today.
Dragon SpaceX with that separation call. We have a few words for you from our Falcon 19.
Standing by.
Dragon, Chief Engineer on Dragon to Ground. Bob Doug, on behalf of the entire launch team, thanks for flying with Falcon 9 today. We hope you enjoyed the ride and wish you a great mission.
Thanks, Bala. Congratulations to you and the F9 team for the first human ride for Falcon 9. And it was incredible. Appreciate all the hard work, and thanks for the great ride to space.
Copy all.
Oh, and proud of you guys and the rest of the team. Thank you so much for what you've done for us today, putting America back into low Earth orbit from the Florida coast.
Copy all. Good luck. Godspeed.
It was a case of second-time lucky for the mission, which had to be scrubbed earlier in the week due to bad weather caused by Tropical Storm Bertha. US President Donald Trump and Vice President Mike Pence flew to the Cape to witness the historic flight, the first ever manned launch undertaken by a commercial company. SpaceX controlled the launch of the Falcon 9 rocket from Kennedy's Launch Control Center Firing Room 4, the former Space Shuttle Launch Control Room, which SpaceX has leased out from NASA as its primary launch control center. As Crew Dragon 2 ascended into space, SpaceX took over command of the spacecraft from their Mission Control Center in Hawthorne, California. Meanwhile, NASA monitored space station operations throughout the flight from their mission control, the agency's Johnson Space Center in Houston, Texas. 19 hours after launch, the Crew Dragon 2 capsule docked automatically to the PMA-2 pressurized mating adapter on the space station's Harmony module as crews on both Dragon and the orbiting outpost monitored events. The validation flight mission's expected to remain there for at least 30 to 90 days, but it could stay as long as 120 days, depending on how the capsule performs. Behnken and Hurley will work as part of the Expedition 63 crew during their stay on station. The test flight was the first under NASA's new Commercial Crew program, which sees SpaceX, together with Boeing CST-100 Starliner capsules using Atlas V and later Vulcan Centaur rockets, take over American crew transfer services to the space station from the Russians, who have provided the only means of reaching the orbiting outpost since the mothballing of NASA's space shuttle fleet following STS-135 in July 2011. The Russian Federal Space Agency Roscosmos has been charging NASA $80 million per seat to ride their Soyuz to the space station. NASA's already using SpaceX Falcon 9 launch vehicles and Dragon capsules, together with Northrop Grumman, Antares rockets and Cygnus cargo ships, to fly supplies and equipment to the space station under its Commercial Crew Resupply Services program. And they'll soon be joined by a third contractor, Sierra Nevada, who'll use Atlas V and later Vulcan Centaur rockets to fly their Dream Chaser winged spaceplane on supply missions to the ISS from next year. Contracting out missions to the space station is designed to allow NASA to focus on longer deep space Artemis missions to the Moon and eventually onto Mars and beyond, using their new Orion capsules and SLS heavy lift rockets. This is SpaceTime. Still to come, astrobiologists put the technology of NASA's new Mars rover to the test, and Japan says farewell to an old friend with the final launch of their H2 rocket. All that and more still to come on SpaceTime. NASA is slated to launch its Mars 2020 Perseverance Rover on the 17th of next month on its historic mission to search for signs of life on the Red Planet. If all goes well, the car-sized six-wheeled mobile laboratory will land in an ancient dried-up river delta in Jezero Crater in February next year. The landing site is ideal, with vast amounts of alluvial sediments washed down from the surrounding landscape likely to be deposited there, providing a treasure trove of both geological samples and potentially biological ones as well. That is, if they exist. But one of the big questions facing astrobiologists is really quite a simple one. How will they know they've actually found evidence of past or present life? After all, the original soup tests carried out on NASA's Viking lander missions back in the 70s were also looking for signs of life on Mars. They did it by mixing Martian soil with various nutrients and then adding water to see if there's any sort of biochemical reaction. However, when positive results were achieved, suggesting some sort of biochemical activity, debate quickly ensued among scientists, with most deciding that it wasn't life on the red planet at all, simply the highly reactionary irradiated soils. And it's not just debate at long distance. Even right here on Earth, we've seen debate about whether mineralized structures are evidence of fossilized life or simply nicely shaped crystals erupt when scientists examined a Martian meteorite found on Antarctica's Allen Hill site. That meteorite, catalogued as AH84001 and famously discussed by US President Bill Clinton at the time, featured microscopic structures that appeared to be fossilized bacteria. But scientists at the time insisted they were simply too small for any known type of bacteria. That was until living bacteria even smaller than these fossils was eventually found right here on Earth. I know whenever I asked scientists about their opinion regarding the Allen Hills fossils, the answer was usually, had they not known this was a Martian meteorite, they would have thought these were bacterial fossils. But then again, as Carl Sagan would say, extraordinary claims require extraordinary proof. So, asking scientists how sure they really are that what they're seeing is, or at least was, alive, remains a legitimate question. Now, a report in the journal Astrobiology has detailed how scientists have replicated the methods and technology that will be used by the Perseverance Rover on Mars to test for evidence of microbial life in the remote outback deserts of South Australia's Flinders Ranges. University of New South Wales astrobiologist Bonnie Teese, who led the expedition, says the technology which will hunt for biomarkers passes muster. Biomarkers are naturally occurring molecules that indicate evidence of microbial life. Teese and colleagues selected the Flinders Ranges because of its barren, dry, dusty and windy environment, which provides a remarkably good analogue when looking for life on Mars. Teese says when looking for signs of life on Mars, or as in her case, for signs of ancient life on Earth, using multiple lines of evidence is really important. Having just a single line of evidence could be caused by contamination, or it might simply look like life but isn't. To overcome this, the Perseverance Rover uses multiple instruments which will investigate items of interest in different ways. The search begins with the Mastcam-Z camera, which can identify far-off rock samples likely to be good contenders for signs of ancient life. The rover's pixel instrument then comes into play. It uses X-ray lithochemistry to reveal the elemental composition of samples, and then the Sherlock instrument to use spectroscopy to analyze the composition of samples, scanning for organic compounds and biosignatures. Teese says by using the same equipment here in her study, she was able to detect samples worth studying and even found organic compound biomarkers of ancient microbial Earth life dating back to the Cambrian.
The rovers, when they go to Mars, they have more than one instrument. They have a variety of instruments so that they can look at rocks and sediments and the environment in different ways. And so we wanted to see how those instruments work together to provide complementary information that might strengthen the case for life if they had found it.
How did you go about doing that?
So we went to the Flinders Ranges and we sampled some stromatolites, which are those microbial structures, and we sampled some areas where there were archaeocyathes. So archaeocyathes is almost a precursor to coral in a way. It's a sponge-like organism, and they made the first animal-based reefs in the geological record. And what we wanted to look at is what were the interactions between these microbial organisms and these archaeocyathes, whether we could detect any signs of life, and whether we could find any of these organic chemical fossils. And if we couldn't, was there anything in these techniques that would tell us that it was a waste of time to look at these rocks and that we should look elsewhere? Because, of course, the rovers can't look at every single rock on Mars. They have to pinpoint which are the best rocks that are the most likely candidates for hosting signs of life.
Where did you go?
So we went to the Bunkers Ranges and we went to near Parachilna as well. So we were looking at the lower and the middle Cambrian, so about 550 million years old these sedimentary rock packages are.
Last time I went to the Flinders Ranges on the expedition I was on, I wound up blowing 3 tyres on the same road. This was a road going out to Arkaroola from Lee Creek, and
yes.
The rocks are so sharp. These were 6-ply tyres, and they still were torn to shreds. Very rough condition.
We went out to Arkaroola as well, and what I was struck by were the amount of kangaroos. You know, when you drove at at dusk or at dawn, the kangaroos essentially lined up at the sides of the road, and you were driving very, very slowly in case one jumped out at the road at you.
Yeah, I never drive dusk or dawn or at night in the outback, only in the middle of the day, because I don't want to hit one of those poor animals.
We tried to avoid it, but unfortunately sometimes when you're looking at the fossils, you lose track of time because you're arguing about where the fossils came from, whether these are good samples to collect, and what you're actually looking at.
Of course, that entire area has become renowned among fossil hunters.
Yeah, so the Flinders Ranges, apart from being home to an incredibly preserved Cambrian rocks, which are the 540 million years old, they also preserve an area, geological time called the Ediacaran, which is named after the Ediacaran Hills in the Flinders Ranges. And this time period is very important because this is where we see differentiation of animal body tissue and specialized organ compartments. And this is where we think the first animals were evolving and interacting with one another.
Our own ancestors.
Yes, exactly. That's right.
Indeed. How do you know something is a representative of what was once, or maybe still is, life?
Yeah, that's quite difficult, particularly when we're looking for life on other planets that might not be the same life as we recognize on Earth, because, of course, we only have one sample size of life on Earth, and that's all carbon-based. I guess what we're looking for in terms of life is something that we recognize as life. So if you're looking at organic molecules, you'd want an organic molecule that you recognize as life. So, for instance, we all know of cholesterol. It's something that we find in our medical tests as humans quite often. And when an animal or a human with cholesterol in its body dies, the cholesterol degrades and it becomes something called cholestane, which is a fossil of cholesterol. So if we found cholestane in geologic record, we would recognize that as a signal for life because it's only linked with life.
That's the only one, just chemical signatures of things that were once alive?
We can also look for physical textures. So, we're quite familiar with bones and stromatolites and trilobites and all of that sort of stuff. We wouldn't expect to find any fossils of animals on Mars, but we might expect to find fossilized stromatolites, which are structures of layers of bacteria. And stromatolites on Earth represent the first 2.5 billion years of evolution on Earth. And so when Mars was once warm and wet,
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
At the same time that Earth was warm and wet, we recognize a lot of fossils from that point in time. So we would maybe expect to find that on Mars. And also we can look for things like minerals, which are associated with biology. Some types of minerals only form on Earth if they're related to types of life. So we also look for those things.
Of course, one of the problems with those last two was demonstrated in the Rose Garden of the White House a few years ago, well, quite a few years ago now, I guess, and that's the Allen Hills meteorite 84001. Yeah. I've seen those crystal structures that they found. For people who aren't aware of it, the US president at the time, Bill Clinton, had a press conference. During that press conference, he talked about the possibility that evidence of life may have been discovered on Mars in the form of crystallized structures which were found inside a meteorite. Now, this meteorite was actually found in Antarctica at a place called Allen Hills, and it had little individual rectangle-like, oblong-like crystal structures which looked like they could have been bacteria, but they were too small. But they really did look like they were bacteria. The debate continued for a while as to whether it was possible that these crystal structures, were they simply minerals, or were they fossilized evidence of bacterial life?
Yeah, that's right. And because as a result of that debate surrounding Allen Hills, the research into what equals a biosignature, I guess, has really been refined. And there's also been instances of very old ancient life on Earth, which have been debated to say whether these were life forms or not. And based on this, many scientists and astrobiologists at NASA have started to produce guidelines for life detection. Recently, in 2018, there was a paper that looked at the ladder of life detection, and it basically ranked the different types of things that you could find in terms of whether that could be excluded as something that looked like life but isn't, or whether that was something that was likely to be life. And you really want to find more than one line of evidence. It really needs to be multiple lines of evidence that indicate life so that we aren't falling for these false positives.
You were looking for specific types of rocks too, weren't you? Rocks that would not have been heated too much.
Yeah, that's right. So because of tectonic plates on Earth, rocks tend to get pushed together, they get heated up and they get pressurized, and this will change a sedimentary rock to a metamorphic rock. It starts to metamorphize away from becoming sedimentary. And when this happens, organic compounds inside the rock start to get destroyed. They crack and they break down into smaller components until they become something that you can't use to diagnose life because the fragments just aren't recognizable anymore. And so this is something that was quite key. We found that from using the techniques, we could tell which of the rocks were the best preserved of the rocks that we were looking at. And so we could then tell which rocks would be most likely to still hold those chemical signs of life without being destroyed.
Is that something you need to worry about on Mars? As far as we know, there's no plate tectonics on Mars, so I guess the only way you're going to get metamorphic rocks is from meteor impacts, things like that, ejecta.
Yes, NASA has previously detected organic compounds on Mars, and it's been quite confusing because those compounds could be actually generated by meteorite impacts, because certain types of organic compounds, which are aromatic compounds, get generated from heat. And so the detection of chlorobenzene has been thought to have occurred because of a meteorite impact. And so although on Mars you're not worried too much about plate tectonics, there is the added issue of radiation because there's no atmosphere to protect from radiation. And so these compounds can be destroyed by radiation as well.
And radiation and reactive source is one of the big issues with the Viking landers as well, when they carried out a number of experiments looking for signs of present life. And it turns out a lot of the experiments didn't account for the unique environmental conditions on Mars, such as reactive soils.
Yeah, that's right. The environmental conditions on Mars are so different than the ones that we look at on Earth. And so that's sort of hard to predict for when we don't know what we're looking at. Luckily now, with decades of Mars research, there's a really good understanding of what the environment of Mars is like, at least at the surface. And we're really beginning to be able to pinpoint and drill down to certain areas.
That's Bonnie Teese from the University of New South Wales. And this is Space Time. I'm Stuart Gary. Still to come, Japan says farewell to an old friend with the final launch of their H2 rocket. And later in the science report, new studies show that chloroquine and hydroxychloroquine offered no benefit for patients with COVID-19. All that and much more still to come on Space Time. Japan has launched a cargo ship carrying 4 tons of supplies to the International Space Station. The flight was the final mission for both the Japanese Aerospace Exploration Agency's H-2B launch vehicle and its Konatori, or White Stork in Japanese, HTV cargo ship. The 56-metre-tall H-2B is being replaced by the new H-3 rocket, which will use more economical engines, while the HTV cargo ship is making way for the new updated HTVX, which will have greater payload capacity and a new automated docking system, replacing the need for the space station's robotic arm to grapple the spacecraft and maneuver it manually into a docking port. The International Space Station was flying 412 kilometres above the Atlantic Ocean just off the coast of Brazil as the HTV-9 mission blasted off into black early morning skies from the Tanegashima Space Center in southern Japan.
Launch Pad 2 on the Yoshinobu Launch Complex, where it is early Thursday morning and where the Japan Aerospace Exploration Agency's H-2B rocket stands fully fueled, ready to lift off on a delivery run to the International Space Station. Encased in the launch shroud on the top top of the 186-foot-tall rocket is JAXA's unpiloted H-2 transfer vehicle, the HTV-9 cargo craft, also dubbed Kanatori, the Japanese word for white stork. This is an historic occasion for JAXA, the final launch of an H-2B rocket that made its debut in September 2009 with the launch of the first HTV cargo ship. Today, we'll be witnessing the final flight of the current genre of HTV vehicles. JAXA is currently developing a new and improved class of HTV craft called the HTV-X. The next generation of HTV cargo craft will be launched on the Japanese Space Agency's new H-3 rocket. T-minus 14 seconds and counting, standing by for engine ignition. We have engine start.
Activated internal batteries. All settings are go. Main engine started.
And we have liftoff. A rising sun over the land of the rising sun as JAXA's H-2B rocket and the HTV-9 cargo craft take flight. Roll, pitch, and yaw program in effect. The H-2B rocket takes flight to the International Space Station.
SpaceX 2:31 a.m.
Liftoff occurring right on the dot at 12:31 p.m. even Central Time, 2:31 a.m. Japan time. Just passing 1 minute into the flight, everything continuing to look good. 4 solid rocket boosters, 2 liquid fuel engines propelling the HTV-9 towards its preliminary orbit, coming up on the 1 minute 30 second mark into the flight. Coming up on solid rocket booster shutdown and separation. And we have solid rocket booster jettisons. First stage engines are continuing to fire, as they will until about the 5 minute 46 second mark into the flight, at which point those engines will shut down, the first stage will separate. And now we have confirmation of separation of the first and second stages. Meanwhile, the International Space Station has crossed the west coast of Africa, moving from southwest to northeast, and we have a report of second stage shutdown on time. We'll be standing by for spacecraft separation moments from now. We have confirmation of spacecraft separation, the HTV-9 now in its preliminary orbit, a flawless launch and a flawless climb to orbit for the final HTV vehicle, now well on its way to the International Space Station.
The 12-ton supply ship successfully rendezvoused with the space station 3 days later. Included in the manifest are fresh food and supplies, new scientific experiments, and the 11th and final group of express multi-purpose payload racks designed to support a variety of different scientific research experiments. Each rack's about the size of a refrigerator and comes equipped with up to 8 configurable lockers and 2 drawers to house various experiments, providing each with its own individual power supply, temperature control, command and data communications network, and protective transfer storage unit for ultimate return to Earth when the experiment's complete, depending on the varying times required for each experiment. The missions also delivered 6 new lithium-ion batteries needed to complete an update of the orbiting outpost's electrical system. The batteries and corresponding adapter plates will replace the aging nickel-hydrogen batteries for 2 power channels on the station's far starboard S6 truss segment through a series of spacewalks by the space station crew later this year. This is the final set of batteries to be launched to the space station as part of an overhaul upgrade of its power systems, which began back in January 2017. This is SpaceTime. Still to come, the science report, where studies show chloroquine and hydroxychloroquine are offering no benefit for patients with COVID-19. And paleontologists discover a new Australian species of dinosaur. All that and more still to come on SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study shows that the anti-malarial drug chloroquine and its analogue hydroxychloroquine, taken with or without antibiotics, offered no benefit for patients with COVID-19. The study, reported in the Lancet Medical Journal, analysed data from nearly 15,000 patients with COVID-19 who were given either chloroquine or hydroxychloroquine, either with or without an antibiotic. and a further 81,000 COVID-19 patients who acted as controls. Chloroquine is an anti-malarial drug, and its analogue hydroxychloroquine is used to treat autoimmune diseases such as lupus and arthritis. The authors found that treatment with these medications, although generally safe when used for autoimmune diseases or malaria, was linked to an increased risk of serious heart rhythm complications for COVID-19 patients. They say that overall, each of these drug regimes was associated with decreased in-hospital survival and an increased frequency of ventricular arrhythmias when used for treatment of COVID-19. New satellite data is showing that climate change is turning parts of Antarctica green, with large blooms of algae creating patches of bright green snow. The findings, reported in the journal Nature Communications, are based on the first large-scale map of microscopic algae on the Antarctic Peninsula. Scientists are using the data to assess the speed at which the continent's turning green, as warmer temperatures create increasing landscapes of slushy conditions which are allowing the algae to thrive. Researchers identified 1,679 separate blooms of green algae snow, mostly on low-lying islands. Researchers from Monash, Swinburne and RMIT universities have successfully tested and recorded the fastest ever internet data speed from a single optical chip, capable of downloading 1,000 high-definition movies in a split second. A report in the journal Nature Communications claims scientists achieved a data speed of 44.2 terabits per second from a single light source. They used a new device that replaces 80 lasers with a single piece of equipment known as a microcomb, which is smaller and lighter than existing telecommunications hardware. It was used in a field trial with existing infrastructure and sent data down each channel, simulating peak internet usage across 4 terahertz of bandwidth. The authors are now working to scale up the current transmitters from hundreds of gigabytes per second towards tens of terabytes per second without increasing size, weight, or cost. Paleontologists have discovered a new Australian dinosaur. A report in the journal Gondwana Research claims scientists uncovered fossilized vertebrae from an Elathrosaurine theropod dinosaur dating back some 110 million years to the Cretaceous period. It's the first Elathrosaur discovered on the Australian continent. Elathrosaurs were strange-looking dinosaurs which ran low to the ground on 2 legs, had a slender body, long neck, stubby arms, and a delicate toothless skull. Consumer affairs and law enforcement agencies around the world are seeing an explosion in scams as fraudsters and con artists try to capitalize on public fear over the pandemic. Criminals are busy flooding the market with everything from phony cures to fake test kits. Tim Mendham from Australian Skeptics says it seems they're all coming out of the woodwork now.
There's always sort of new claimants coming up, and some of the claims they make are the same old, looking at things that will either treat or cure COVID-19. Unfortunately, obviously, social media has given free rein to a lot of people who should know better or don't know better to propose a lot of things. It's not surprising that it's actually quite rampant within the naturopathy fraternity. They're always putting herbs, cures and that sort of thing. There was a case recently of a lady in Sydney who was offering tests for coronavirus at $130 I think.
Yeah, they're free from the government.
That's right, free from the government. Then when they confronted her, she said, no, I'm not suggesting any such thing. I'm not suggesting any cures or treatments. And yet she was openly on Facebook and on sort of phone calls and that sort of stuff, which they pointed out. And she basically didn't have a leg to stand on from any particular point, either from the cures she was offering or from her claims that she wasn't offering them. So there's a lot of people out there doing that, not just naturopathy, amongst the chiropractic community as well. There's a lot of people offering a whole range of treatments there, which is perhaps surprising or not surprising. There's a great deal of anti-vaccinations sentiment within the chiropractic community. And, of course, the whole premise of chiropractic is based on a premise of the misalignment of the back is responsible for 95% or whatever percentage of all illnesses and conditions through a situation called subluxation, which is supposed to be a misalignment of the back and causing all sorts of nerve issues, which no chiropractor has ever been able to prove, and which a lot of chiropractors admit is an antiquated concept anyway. So there's a lot of anti-science and non-science amongst the naturopathy and chiropractic community around the world. They keep promoting the same old things that, heat will cure coronavirus. Yes, but it has to be a lot of heat. It's unlikely you're going to survive 75 degrees C in your body. All sorts of strange things being put up. Chiropractor in America was putting up the cure of silver colloid, silver solutions. None of these things have got any efficacy proved at all. And so it's sad that they keep going on, but because of social media, they're allowed to. Not always allowed to. Certainly the skeptics in Australia, there's a big campaign at the moment to at least alert the authorities to all of these claims that are being made. I know one fellow who's particularly active in this area gives me a daily update on the latest that he's found.
No, good on him.
And he's alerting the authorities, etc. And the authorities are saying, yes, thank you very much, we'll look into it.
Do they ever look into it, or are they simply overwhelmed and there's not much they can do?
It's a bit weird sometimes. Some of them you might think they regard it as a lesser problem, and they've got more important things to do. Other times the things that they do to the claimant are pretty pathetic, like a slap on the wrist and say, don't do it again. And they take a thing down off their Facebook page and put it up again under a different guise later on. It's a major issue, quite frankly, in Australia, and I'm sure elsewhere as well, that our regulators are not that strong.
Is that because they're not funded properly, or the laws themselves aren't strong enough?
I think it's a mixture. Certainly the funding is an issue. That the resourcing of some of these groups is particularly poor. So they tend to sort of prioritise against major dangerous areas without thinking that a lot of these things that are being put forward are actually dangerous, and create a climate of belief in unscientific and pseudoscientific solutions. It's a very bad situation, especially amongst chiropractors, that we're looking at them very closely. And there's a lot of problems in that industry, which the industry board itself is, I would say, particularly poor in managing or clamping down on.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.